It's so close. For thousands of years, man has found comfort in its presence. It's been a beacon for nocturnal travelers, a timekeeper for farmers, and a location finder for sailors at sea. For some cultures, it's even been a god. It's the only cosmic body ever visited by human beings, and today, NASA is planning a permanent outpost there. But how did it get there in the first place? How did the moon come to be? The answer is more astounding and spectacular than most residents of Earth have ever imagined. At last count, over 150 moons populate our solar system. Neptune claims 13 of them. Saturn has 48. And Jupiter hosts an astounding 62. Earth, on the other hand, has just one. But it's a special one. Our moon, Luna, as the Romans named it, is remarkable in its size. It is by no means the largest moon in the solar system. Several others are bigger. One of Saturn's moons, Titan, for instance, is twice the size. But our moon is the largest in relation to its host planet.
It's a quarter the size of the Earth. It's really big compared to the Earth. If you look through a telescope at the Earth from a distance, you'd see the Earth and this other big thing. If you look at Jupiter or any other planet, you got the big planet and then little tiny moons right next to it. So our moon is so much bigger, and it's the only one of the now 8 planets that has that situation.
The relative sizes of the two bodies are close enough that some astronomers go so far as to refer to the Earth-Moon system as a double planet. The mean distance from the Earth to the Moon is 234,000 miles, a 3-day flight through space. Luna's diameter is roughly 1/4 the size of Earth's, measuring 2,160 miles. A single day on the Moon is the equivalent of 27.3 Earth days. This is because one side of the Moon permanently faces us. Luna is phase-locked with our planet. So the Moon must fully orbit the Earth in order to make one complete rotation on its axis. Sort of like children in a game of Ring Around the Rosie. They always face inward as they hold hands and move in a circle. Yet as closely related as the Moon is to our Earth, it would only take a brief visit to Luna to make it quite clear that it is in fact a very different world from our planet. And an exceedingly dangerous place.
Tranquility Base here. The Eagle has landed.
There's no air, of course, so you need your spacesuit.
Indeed, the Moon has absolutely no atmosphere at all. So there is nothing to carry sound waves. If you were standing on the Moon with a friend and tried to converse, the person wouldn't be able to hear you, except by radio.
I was strolling on the moon one day in the merry, merry month of December.
No atmosphere also means that there are no air molecules to scatter light from the sun. So the sky is always black. And the landscape does little to help brighten the scene.
Kind of monochromatic, not much color there. The rocks are mostly gray-brown colors. It's maybe a little warmer tone in one direction, maybe toward the sun, and cooler tones, grayer tones looking in other directions, but not so colorful.
Extreme temperatures would also add to the unpleasantness of a visit. The swings between hot and cold are brutal, from 270 degrees above zero at midday to 240 degrees below zero at night. Even the moon's low gravity, just 1/6 of Earth's, could present a hazard to a tourist. A reality the Apollo astronauts kept at the tops of their minds during their many moonwalks.
But they realized that beyond the thickness of their visor in their spacesuit was death. Should they do something and fall into a rock and lose their footing and fall and hit an outcrop, this visor could be cracked, exposed to the lunar vacuum. We would have had a serious situation on our hands.
But while a spacesuit could protect lunar tourists against the vacuum of space, a lack of oxygen, temperature extremes, and lethal solar radiation, a potential hazard a spacesuit would do little to protect against is high-velocity micrometeorites. They pummel the lunar surface frequently.
Tiny meteorites, the little ones that burn up in our atmosphere and make shooting stars, there's no atmosphere on the moon. They're coming right down, hitting the surface.
They pulverize the lunar surface, generating a dusty blanket of gravel-like material called regolith. Dr. Amanda Hendricks studies the moon at NASA's Jet Propulsion Laboratory.
This plant here is kind of a regolith factory. It's ground up rock is what it is. The timescales at this gravel mill are a lot faster. Here, it's made in less than an hour. But on the moon, it is the result of more than 4 billion years of bombardment by meteoroids and micrometeoroids raining in on the surface and breaking up the rock.
Like the product of this gravel mill, lunar regolith has formed in a variety of grain sizes, from large rocks to fine dust.
This very fine dust is familiar to us from Apollo images that were seen of astronauts' footprints in the dust. It's very fine, and so fine, in fact, that the astronauts had problems with it sticking to their spacesuits, getting into the equipment, and it can end up causing a bit of a problem.
Really big meteorites have also hit the moon in the past. In fact, these massive impacts are responsible for the dark circular regions on the lunar surface. The shapes that to many observers seem to be arranged like the eyes, nose, and mouth of a human face. They make up the illusion of the man on the moon. They blasted huge basins in the moon's surface. Some of them are 700 miles across. Dark lava eventually burst through at the impact points and flooded the basins.